welcome everybody to our weekly live stream here at the Morrison Planetarium. Now, you're probably noticing one, you can actually see me for once. My name is Christian. I want to be your planetarium presenter. And two, we have a different background. The reason why is because the planetarium, the Morrison Planetarium, is currently closed today for its annual maintenance. So unfortunately, it's closed. So we're doing our live stream here in this new studio with this really cool background. It's a lot of fun. But once again, my name is Christian. I want to be your planetarium presenter. And right now, we're going to be doing one of my favorite shows. This is called Tour of the Universe. So, for the next 30 minutes, I want to start off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. And hopefully, by the end of the show, you won't have an existential crisis of where we are in space, because just to let you know, we're pretty small in the grand scheme of things. And I'm very happy to have y'all here to join us. If you want to share this with friends and family, you can always share this because this show is recorded and share the fun of the universe with other folks. But for now, I'm going to be putting away my camera so that we can focus on the main screen here. And we're going to be starting off at this really amazing feat of human innovation. What we're looking at is the International Space Station, or the ISS for short. And a lot of people don't realize what exactly this thing is. They always hear about it in articles and news, but they always tend to ask me, hey, Christian, what is the International Space Station? Well, just to let you know, folks, the International Space Station is a research facility. It's a laboratory that orbits around our planet Earth. And they conduct so many different types of experiments up here. For one, some of the experiments they'll conduct are things like what happens when you try to grow plants in space? Do the roots grow the same way? Do they grow differently with less gravitational influence? Another one is what happens when you try to spark a match in space? Does the flame act the same? Does that act differently? And one of my favorites, of course, is where they had two identical twins. One twin lived on Earth for about a year, the other one lived on the International Space Station for the year. After that year, they compare and contrasted the two twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not that, just that. You also lose a lot of muscle because you don't have as much gravity constantly working down on your muscles. So remember to exercise daily while you're out here in space if you're ever visiting. And also, folks, this spacecraft looks incredibly large here on our screen, but it's not that big in actuality. It's only about the size of an American football field. So if you've never been to an American football game and you've been to the California Academy of Sciences, well, the museum's roughly about how big the ISS is. And what's really incredible is that this thing is going incredibly fast. The ISS is traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes and experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, what's incredible as well is that this looks really far away from the planet Earth. You can see so many city lights down below, but it's not that far either. The ISS is only about 250 miles above the surface of our world. 250 miles, that's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend. So, not too bad. And to tell you the truth, folks, this is as far as we put humans out into outer space nowadays, only 250 miles above the surface of our world. The reason why is because traveling to space is quite expensive. Got to build yourself a rocket ship, buy yourself one, or pay for a ride, and that can get all quite costly. And not only that, you have to also account for all the food, water while you're out here in space, so it's very expensive. But the International Space Station is just the first stop on our tour of the universe, so now we're seeing it slowly fade away to the city lights down below. And before we lose track of it, I want to add a nice little orbital path so we can see it. And it looks like we're hovering just above Paris, France, as we lose the International Station down below. And now, folks, we're able to see our entire planet Earth from this vantage point. And I want to let you know that the space program that we're using right now for this show is something that you can go home and download if you like. The space program that we're using here is called OpenSpace Project. So if you go to www.openspaceproject.com, you can come across a link and you can download this, and it's so much fun to fly through space. But just a heads up, OpenSpace is not entirely finished. It's in its beta phase, so there still needs to be work on it. But what's really amazing is that this is an open source program. So if you know computer language and you like to add models into computer programs, this is a fun program that you can download and add cool new things to it. So it's a whole lot of fun. Also, it uses a whole lot of processing powers. It pulls from satellites that are orbiting around our Earth. So all this imagery that we're seeing, this is what the weather looked like on Earth yesterday. So uses a lot of information. So just a heads up while downloading this. But now that we got an idea of what we're using here for our show, let's make our way over to our nearest natural neighbor to us in space, the moon. And folks, we humans have been to the moon before. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, of course. They had some fun up here as well. They got to play some golf. But again, the last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years, thanks to a new space mission in the works by NASA called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars. But before we send humans to Mars, we need to figure out exactly how we're going to be living out here in space. So the moon is the perfect stepping stone to figuring out the logistics of doing that. And what's really amazing is that they're going to be sending the first woman to the moon. But not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also going to be setting up lunar bases throughout our moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to conduct much more science in a much more compactable size. And one place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we found ice there. And that's going to be very helpful because we can melt that ice, pass electricity through it. We could separate the hydrogen and the oxygen, and both that stuff's really valuable when you're far away from home. So again, we humans should be heading back to the moon relatively soon. So look out for any news about Artemis. And folks, sometimes when we're looking at the moon here from planet Earth, it feels incredibly close. It feels like you can reach out your arms and touch it. But the moon's incredibly far away. It's about 240,000 miles away from our planet. 240,000 miles. Some of the adults watching this program right now may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine if you drove to the moon for about 4 months nonstop, going about 80 miles per hour. Although we don't recommend that, the roads out here are poorly maintained. Hee hee hee. And from here on now, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so vast, it's so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds at the speed of light to cross that distance. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye bye, moon. And now, just like before, we're going to see the moon start to slowly fade away into the vastness of space. And just like before we lose track of it, I want to add some planet trails so we can keep track of all the objects in the solar system. Because again, space is really big. And on our journey today, folks, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models showing us the most accurate images and information available to us. And now the nearest star to us, the sun, should be coming into view. So here comes the sun. Do 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 do. And also, the sun is incredibly far away as well. It's about 93 million miles away from our planet Earth. Whew, 93 million miles. That is a good distance away. Now, in terms of speed of light, that's not too far away per se. It only takes sunlight about 8.5 minutes at the speed of light to travel that 93 million miles. And again, we're the third rock from the sun, so we got one, the closest planet, Mercury, Venus, and Earth, 93 million miles between us, 8.5 minutes to travel that distance. And this is a great concept to keep in mind because it takes light time to travel far distances. And again, this is such a cool concept to keep in mind because let's say we're looking at a star that's 70 light years away from us. Well, we're looking at that star as it looked like 70 years ago because the light that just reached us took 70 years to get to us. So when you're looking at really far away objects in space, it's kind of like looking back in time in a sense, which is really neat. But now that we have a nice bird's eye view of our solar system, let's do a quick refresher of what we have. Right in the middle of our solar system is our star, the sun, the biggest thing by far. The closest planet to the sun is going to be Mercury. The second one is going to be Venus. The third one is going to be Earth. That's us. And then the fourth one is going to be Mars, the famous red planet. And then after Mars, we have the main asteroid belts. And this is what it would look like if we were to highlight all those asteroids. There's roughly about 1 million asteroids in the main asteroid belts. So quite a few. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We have Jupiter, the largest of them all. Then we have Saturn, famous for its rings. And then we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can always add everyone's favorite and lovable dwarf planet, Pluto. So here comes the orbit of Pluto on screen. Just on the outer left of our screen there, just appeared. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And a lot of folks tend to ask, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. Yeah, there's a lot of stuff out here. And so the Kuiper Belt is essentially a second asteroid belt. What you're mostly going to find out here are icy asteroids and short period comets, comets that don't stray too far away from the sun. And what's really fascinating is that we kind of came across all this stuff back roughly around in 2006. Our technology greatly improved, so we're able to see much smaller objects much further away. And in 2006, we came across more than 400 objects in the Kuiper Belt region. Some of this stuff was bigger than Pluto. So we couldn't call all these things planets. There was just way too many of them. So all the astronomers on planet Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet, and they came up with three different criterias. And folks, that was the day in 2006 that Pluto went from being a planet to a dwarf planet. And I know a lot of you people still have hard feelings about that, but that's the really neat thing about science. It's constantly updating and changing as our technology improves. So as our technology improves, we're able to make better classifications. So that's one of the things I love about science. It's constantly changing. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And now I'm going to be adding on screen some of the many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto back in 2015. If you see the orbit of Pluto, you can see a spacecraft line that just passed it. Now, all of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventures, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight roughly about 5 hours at the speed of light. 5 hours to get all the way out there? That's not too bad. But now, folks, it's time for us to leave our planetary scale behind us because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us roughly about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And it looks like Alpha Centauri just flew by on the very top right of our screen. You can see that star that's moving really close relative to us. We're right in the center. Alpha Centauri is just a little bit to the top right. And again, 4 years at the speed of light just to reach the next star system to us, folks. But that doesn't put into perspective of how long it would take us humans to travel that distance. Well, if you were to get in a rocket ship today, made your way over to Alpha Centauri, it's going to take you roughly about 8,500 years to make that trip. And that's just a one-way trip. I don't think I can live that long. But now let's stop and consider whether humanity has made its presence known beyond our solar system, because now, folks, we're stepping inside something called the radiosphere. And again, we're now inside something called the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted or rather leaked into space. and it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year. So is anybody out there listening? And now, folks, I'm going to be adding these many markers onto the screen. These many markers indicate the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets. And we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than 5,000 confirmed exoplanets in the nearby vicinity to us, 5,000 of the world's besides our own. And that 5,000 number is going to be increasing as the years continue because we have spacecrafts where their whole purpose is to find as many exoplanets as possible. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. But new spacecrafts are being developed, created right now, so we got a few years before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. And of course, planetary systems more than 90 light years away have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, folks, I'm going to be putting away our exoplanet markers away, and I'm going to leave our radiosphere up on screen. Because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy, so keep your eyes on it. And now, folks, we're looking down on our Milky Way galaxy. This is the galaxy that we live in. And I've got to ask, can anybody see their house from here? Just kidding, of course. And folks, our Milky Way galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you roughly about 130,000 years at the speed of light. This thing is really big. And our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way, I want to show you what it looks like from a sideways perspective. As we start to swing around here, and I realize that we live in this big flat spiral disk. Kind of looks like a big frisbee or pancake in space. And this is important because when astronomers want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and south instead of looking through the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So again, we like to point our telescopes galactically north and south instead of looking through the plane. So we like to look up and down. Keep that in mind. That's going to come important in just a little bit. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as we continue expanding out, folks, you're now going to realize that galaxies, they're not evenly distributed throughout space. Instead, they like to clump together in large groups and clusters whether they create those clusters or they create voids or where there's very few galaxies. So we can see some nice galaxy clustering towards the center of our screen. If we look off to the left over here, you can see very few galaxies or no galaxies at all. So you can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And now, folks, we've zoomed so far out, this picture that we're now looking at represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing researcher by the name of Dr. Brent Tully, who compiled this amazing representation over decades of time with the work of dozens of other astronomers working aside him. So, big shout out to Dr. Brent Tully. I love flying through this galactic map. But now, folks, we have automated systems that are mapping even the most distant galaxies. So now we're about to look at the large scale structure of the universe. And remember, every single point of light that you're seeing, that's not a star, that's an individual galaxy. And as we start to swing around the large scale structure of the universe, I just want to let you know that the large scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in a big flat spiral disk of the Milky Way? Well, if we were to line it up, it would line just like so, up and down. So again, we like to point our telescopes galactically north towards the left of our screen and galactically south towards the right of our screen. And the reason why we're missing galaxy data in the spots where they're missing galaxies is because, again, remember, it's tough for us to point our telescopes through the galactic plane of the Milky Way. So once our technology improves, those areas will be eventually filled in. So it's just a matter of time. We're just waiting for that technology. But let's continue pressing on, folks, because now we're going to be encountering these really distant, faraway objects known as the quasars. Now, the quasars are going to be represented by orange dots on either side of the large scale structure of the universe. And quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, before stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the very edge of the observable universe. What we're looking at is something called the cosmic microwave background image, or the CMB image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old. This is data compiled by Planck and other radio telescopes. And this picture is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image where the light echoes of the Big Bang are color coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these tiny differences eventually gave rise to that large scale structure of the universe, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But now that we've traveled as far back as the law of physics can physically allow us to go, we only have one direction left to go. That's going to be back towards home, towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. Ooh, this looks like a good spot. And let's make our return trip back home, folks. Now, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of the night sky. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we made our way back into our Milky Way galaxy. We're flying right through that radiosphere, and we're making our way back into our solar system, our little neighborhood in the vastness of space. And now we're about to pass those spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto in the Kuiper Belt region, making our way to the third rock from the sun, our homeworld planet Earth. All the people that we know, love, ever learned about in history all lived on this one planet. And now we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our Tour of the Universe show. And I want to thank you all for stopping by and watching it with us today. I hope you did enjoy it. But hey, look at that. We made it back in time, just in time for dinner time. And again, I want to thank you so much for stopping by. And I hope you all have a great rest of your day. And take care, signing off, and enjoy your evening, everybody.